Hello my dear students and welcome to Zenith Academy Online. You all know me, my name is Shagufta Jaipuri and today we are doing a very important concept of physics, that is the concept of resistance. What is resistance? So the knowledge of resistance is very important before studying the topics like current, electricity. So let us talk in detail about resistance today. So in this video lesson we are on part 4 of the chapter electric circuits for GCSE physics O level, that is year 11 students. And in this video module we will be talking about the concept of resistance. Now we all know that when a metallic conductor is there and it is not connected to any potential, that is if the battery is not connected, you see that electrons keep on jumping and colliding with each other and the stable atomic ions. So in a metallic conductor there are stationary metal ions and there are free electrons. So when you attach a battery at the ends, there will be a potential created. So electrons will start drifting towards positive side, and when there is a flow of electrons, we know current is formed. So the current is formed or the current is generated opposite to the direction of flow of electrons. So now we know when this potential is applied, the electrons start drifting towards the positive side, but when they do so, they do not move very smoothly. They keep on colliding with each other and also with the metallic ions. So they do not do it in a high speed. Okay, they drift slowly. What is the reason why there is an obstruction in the flow of current? So let us study that. See, if this is voltage, if this is Mr. Voltage and voltage is trying to push the electrons. So we know whenever there is a voltage applied, that is there is a potential difference across the two ends, then the electrons start to flow. But here you see there is some obstruction, the electrons are not flowing smoothly. So when voltage is applied, there is some obstruction, and this obstruction to the flow of current is known as resistance. So here you can see a very small amount of current that is flowing. So what is this obstruction? Why electrons are not pulled by the positive charge very quickly? Here you can see Mr. Voltage who is pushing the electrons and hence creating current. But here you can see Mr. Resistance. What he is doing is obstructing the flow of these charges. Okay. So let us talk about Mr. Resistance today. That what is it? Why there is an obstruction? So here you can see there are these metal ions which are stationary. So when electrons are pulled towards the positive side here, they do not move straight. They collide with these stationary particles or stationary metal ions. They also collide with other electrons. So there will be other electrons also who will be traveling. Okay. So they keep on colliding. So this collision leads to the slow down of the movement of electrons. That is why, since they do not move very softly, they keep on colliding, they keep on jumping, and then they slowly reach that side. So that is the reason, the presence of stationary metal ions and the collisions. So here you see there are more collisions. So you can say that this metal ion is giving less obstruction to the flow of current, and with this diagram you can see there is more obstruction to the flow of current. So it is becoming very difficult for this negative charge to go here. So it will take a longer time and hence less amount of current is obtained here. So whenever there is a less current flow, you say that the resistance is high. So resistance is high. So this material is offering more resistance and this material is giving less resistance. So from this diagram we have a slight idea that when electrons are trying to move towards the positive side, there is an obstruction from the stationary metal ions and from the other electrons that keep on colliding with each other. You can see if this substance is providing less resistance, the electrons are able to move quickly, but here if you see there is more resistance, the electron takes time to move. You can see in this circuit I have attached a resistor, and here I have attached 4 resistors in series. So this is offering more resistance and this is offering less resistance. So you can see the one who is offering less resistance, the bulb glows brightly, and the one who is giving large resistance, the bulb is glowing dimly because less amount of current is flowing. So more the resistance, less is the current, and less the resistance, more is the current. Now let us talk about the factors affecting the resistance of a current. What are the factors that affects that how much resistance is offered? Now there is this formula, R is equal to rho L upon A. So R is the resistance, this rho is resistivity, which depends on the material of the wire or the substance. Then this L is the length, you can write small l also, L is length, and A is the area of cross section. So we can say that the resistance, you can see with this equation, that resistance is directly proportional to this resistivity, which depends on the material. So all the different materials have different resistivity. Then you can see from the formula that resistance is directly proportional to length. So the length increases, resistance increases. Now thickness of conductor, you can see resistance is inversely proportional to area. Now what is area? If you see here, this is the area. Area of cross section is basically a circle. Okay. So if we write the formula R is equal to rho L upon A, this is area. So what is the area here? Instead of A, we can write pi R square, because the area of cross section is a circle where R is the radius of this circle. So we can say R is inversely proportional to area, or we can also say that resistance is inversely proportional to the square of the radius of this area. Now it also depends on the temperature of the conductor. So here you can see, if this is the metal wire, this is considered as the length, this is considered as the area, and rho is the resistivity, which depends on which material the wire is made up of. So now let's talk about all these factors in detail. The first factor is nature of conductor. All materials have some resistance, but certain materials resist the flow of electric current more or less than other materials do. Materials such as plastics have a high resistance to electric current, and they are called electric insulators. Those that have a very high resistance, that means that they will not allow the current to pass through them. They resist the flow of current a lot. So they are known as insulators. Now, materials such as metals have low resistance. Now metal has low resistance, that is why they allow the current to pass through them. So materials such as metals have low resistance to electric current, and they are called electric conductors. And we all know that resistance is directly proportional to resistivity. Now this is resistivity, and this is also known as specific resistance. Now what is specific resistance or resistivity? They are unique properties of the materials. So copper has a different specific resistance, iron has a different specific resistance, and plastic has a different specific resistance. So that is why, depending on the resistivity of the material, the resistance is decided. So we can say that resistance of a conductor is directly proportional to its nature of material. Next is length of conductor. So suppose this is one wire and there is another wire like this. Both are having the same thickness. Now since here the electrons will have to travel a larger path, so there will be more number of stable or stationary metal ions. So this electron will keep on colliding with them and then it will reach. Okay. But here these electrons, even if there are metal ions, there are less number of metal ions, so the collision will be less and it will reach fast. So here, since the number of metal ions will be more, since the path followed is more, the resistance will be more. So we know resistance is directly proportional to length. The longer the wire is, the larger will be the resistance. So here if we say This is the resistance offered by this wire and this is the resistance offered by this wire. So we can say resistance 1 is more than resistance 2 because here the length of wire 1 is more than length of wire 2. So a longer wire has more resistance than a shorter wire. Current must travel farther through a longer wire, so there are more chances for it to collide with the particles of matter. Now, next is thickness of conductor. So we had seen this diagram. So here you can see this is the thickness. Okay. So the thicker the wire is, the more will be the area. So if I draw two wires like this, one wire is like this and another wire is like this of the same length, but here you can see this is more thicker than this one, or we can say area of one is more than area of two. Area of one is more than area of two, you can say. So thicker the wire, a wide wire has less resistance than a narrow wire. So if the wire is thick, the electrons will have more space to travel. Now just think of the wire as a railway platform and the total number of people on the platform is fixed. Now if there are many people in the platform, okay, if you have to go from one point to another, you will keep on bumping into each other and then you will reach the other point. Now if you widen the platform, right, if you are widening the platform, keeping the number of people same, so now you have more space to travel, so you will reach quickly. Now since there is more space for you to travel, you can reach that place quickly. There is less resistance that is offered by other people who are standing. In the same way, if the area of cross section is more, that means the wire is broader or wider, or if it is a large area, that means the resistance offered is less. And we also know by the formula that R is equal to rho L upon A. From this it is clear that this resistance is inversely proportional to area. So more the area, less will be the resistance. So it is inversely proportional to thickness. That is why wide wire has less resistance. Okay. So electricity flowing through a wire is like water flowing through a hose. More water can flow through a wide hose than a narrow hose. In a similar way, more current can flow through a wide wire than a narrow wire. So if we take this as a hose, more amount of water can flow through this, whereas here less amount of water will flow. So this water is an analogy to current. So wider the wire, more is the current. More is the current means less is the resistance offered. Now, the next and the last factor which affects the resistance is temperature of the conductor. Now, we know that when we increase the temperature of a substance, the kinetic energy of the particles inside the substance will increase because heat is being provided. They gain the energy from heat and they start colliding with each other. They start jumping and colliding with each other. So when their kinetic energy increases, the number of collisions of the free electrons will also increase. And if the number of collision increase means the resistance is increasing. So you can say a cooler wire has less resistance, means temperature is less, resistance is less. So resistance is directly proportional to temperature. So a cooler wire has less resistance than a warmer wire. Cooler particles have less kinetic energy, so they move more slowly. Therefore, they are less likely to collide with the moving electrons in a current. And materials called superconductors. Now, this is very important. The superconductors have virtually no resistance when they are cooled to extremely low temperatures. So, the superconductors at extremely low temperatures provide almost zero resistance. That means the current can flow very easily through it without any loss. So now we know what are the factors that affect the resistance. It is the material which is directly proportional to the resistance. Then it is length which is also directly proportional, area which is inversely proportional, and then the temperature. So we should always remember this formula. R is equal to rho L upon A. With this formula you will be able to answer all the questions related to factors affecting the resistance. There are many numericals also asked on this section, that what happens if you double the area or if you double the length by stretching or just keeping it over it. So we'll be discussing all the numericals of this chapter later on in another video. Right now this was all about the concept of resistance, that what is resistance, why it is offered, and what are the factors that affect resistance. So I hope you have liked the video and you have understood the concept very well. If you really like the video, give it a thumbs up and write your comments in the comment section below. And if you have not yet subscribed to our channel, please subscribe it right now, and don't forget to tap on the bell icon to receive all the notifications of all the interesting topics that we keep on uploading. If you like our channel, please spread it across your friends and keep the learning on. Thank you and have a nice day.